Hello guys, welcome back to this tutorial. So this is going to be a brief one. So we want to create a simple pendulum from the tutorials that we did. So we open model like that. We need to open the cylinder in which we assigned the initial conditions. I saved it as IC. We want to put a revolute joint here at point 0. And now for point 0, once you put a revolute joint, it will remove 5 degrees of freedom. And we'll check that. So usually for you to check that, you come here to check model, but before, so that you can inspect degrees of freedom, you have to make sure that you check everything here. It's checked. So once you check that, then you can come and inspect the model, and then you can see that it has. For instance, let's check this model, and then we see the degrees of freedom that it has. As you can see, degrees of freedom, DOF, not counting redundant constraint, is 6. So if you have a redundant constraint, the software itself will guide you on what to do. But I believe we'll do that at some point. So we add a joint here, right click here, and then you come here to revolute joint, allow compliance, okay. Now once you do that, it's a revolute joint, body 1, select body 1, double click, you come free body part is the body 1, and then body 2 is the ground body, like that. Joint 1, so this is the origin where you are going to put our revolute joint. We put it there. Then for the alignment, you see it's lying along the XY plane, but you want it to lie along the ZX plane. Now we click here, drop down arrow, vector. So once you click vector, you select global Y, like that. Now as you can see, now our revolute joint is there. Let's come and check the model, and then we see what happens. Come here, and then you will see degrees of freedom removed by joints is 5. A revolute joint usually removes 5 degrees of freedom. We only have 1 degree of freedom. Now we want to run this simulation. So you come here, we need to save this model first. Save as, and then we say simple pendulum. Like that. Now we say save like that, so that here once we run, it gets the other files in as simple pendulum. So we run this. So we have to change this time to 5 seconds, like that. Then we run it. So after running this, you'll find that here there's something we want to check here, dynamic analysis, because we have an initial condition that we had already put. So we have not even constrained the oscillation there, the motion. So let's see what happens. We animate this in hyper view. Let's play. You see now it should spin because we have not constrained anything, so it's just spinning around the joint. So for revolute joint, we must add our own motion. Now we right click, we add motion, and then here for the motion on joint, like that, not using markers. And once you double click there, joint 0 is the only one that will be active because our revolute joint is on joint 0. If it was on joint 1 here, we'll have had joint 1 here. So if you have 2 joints or 3 joints, you are the one to decide how you want it to be. Now here you leave it at displacement, type is rotational. Now we come here. Now we define this one by expression so that we make the angle that we want. As you can see, we have 2 dashes here. Come and type in between them, because some of the keyboards don't have that front dash, front dash. I'll show what I mean. Times, time, like that. So if you use the other, is it comma or what, that one, apostrophe, that one, you'll get an error. Therefore you have to use the one that's front facing. Now let us come. Now we have put our motion. You can see now we have put our motion, and you can filter this by motion. So you see that's motion. Now we can filter it. Now you come here to the model, not model tools, we check the model, and then we see now the degrees of freedom that are available. Now as you can see, freedom removed by motions is 1. So we have no 0 degrees of freedom. It's 1, 1 and 0. Now the next thing that we want to do is to come and remove the initial velocity, because you don't need it. So come here to initial velocity, then you come here to initial conditions and check that. Once you uncheck that, then you have removed the initial condition that we had. Now we come here to motion 0. I want to see if we can add, if there is anything we can add, especially the rotational velocity. Yes, we can add velocity here to the joint, the rotational velocity. So you can come here and then initial condition and then rotation. So you can put this one at 15 radians per second. You can even add frictional properties. So if you want to put friction and so on and so forth, so you have that option, but that one is for later. Now we come here, click run, and then once you click run, we run it again, close, then we close that, then we come here. Sorry, we have already closed that. So we already had loaded. So this is for the saved file. So we refresh it and then we see what happens. Now you can see now it's a simple pendulum, as simple as that. Now what we want to do, we want to see the type of oscillation that it has. So in the graph wise, so we come here and then we click plot. You don't need to always come here and select the file that you want to load. Time, and then we can say marker displacement. Is it marker displacement? No, the body, because we want to check on the body and then the free body part. And then I realized that I think it's E2, one of them. No, it's not E2. Yeah, it's this one. Yeah, it's E2. E2, sorry, it was not E1. So you can come here and deselect this one, remove that curve, and then now you can click play. You can see, yeah, you can see how it's going. Yeah, the oscillation is like that. So it's starting at sine, that we use sine because at sine 0 it's 0. So when time is 0, there's almost 0 displacement and so on and so forth. So that's how you do it. You can come here and try and change something and see what happens. So we can come to the joint, connectivity, and then we swap this and then we see what happens. If there's going to be any change, so we say okay, and then this one we put free body part like that, and then come here and then we run again. We close, and then we animate, refresh, and then we see what happens. There is going to be, so no change, no change, no change, because our pendulum is still there. So you can come here again and then you can say plot. We see if there is going to be any change. If you want to see if there is any change, you can even plot here. Let's plot here and then we see if there is any change. We don't need to plot on the other graph. So it's not marker displacement. It's, let us go now to E2. Still the same, so nothing has changed. So you'll find that this is now a kinematic analysis because we have fully constrained our cylinder. So let us see kinematic analysis. As you can see, we have kinematic analysis. So that marks the end of this video. So there's nothing much that you can do here apart from saving this model as, so we save model like that. So it has already been saved, so we've not saved the session. So all this will disappear once we come and load this simple pendulum in the next exercise. Thank you for those who have subscribed. Thank you for those who are watching.